Okay. Sphere is dashed by the metal wire to a horizontal surface at the bottom of a river, as shown in the figure. So and so. The sphere is fully submerged and in equilibrium. This is very important. And for these kind of things, I always recommend a student to circle or underline these kind of words. And angle is 68 that you can also see on the screen. The horizontal surface weight of the sphere is 32 newtons. So weight will be acting like this. This is 32 newtons. If you see there is some information which is in the statement but not on the diagram, you can always add it on the diagram because it is easy to see information from the diagram than from the text. The upthrust acting on the sphere is 280 newtons. So upthrust is 280 newtons. The density of the water is 1 into 10 to the power 3 kg per meter cube. Assume that the force on the sphere to the water flow is horizontal direction. So obviously, if water is coming this way, this will be the force because of the water. Let's call it FW, force of water. Now, by considering the component of the forces on the vertical direction, determine the tension in the wire. Now see, this will be the direction of tension. I'm making an arrow on the diagram. Let me choose a brighter color. So this will be tension. Tension will have two components. One will be like this, P cos 68, and tension will have a downward component, P sin 68. Okay. Now, what two sets we can produce from here? If this sphere is in equilibrium, then one set would be that force of water equals to T cos 68. But the problem is in this set, I will have two unknowns. I don't know the force of water. I don't know the tension. But look at the second set that we can produce. That is T sin 68 plus 32 should be equal to 280. And how many unknowns I have in this one? Only one. Do you think I can use this equation to find value of T?
Yes.
Good. So this is how I do it. T sin 68 plus 32 equals 280. So T equals to 248 divided by sin 68. Okay.
About 270.
48 divided by sorry, did somebody tell me the answer?
Yes, sir. About 270 Newton.
270 Newton. Did you round off everything to the appropriate number of gen figures?
Yes.
Good. So 270. Now, for the sphere, calculate the volume. Oh. The formula that you have to use is upthrust equals to volume into density of the liquid into gravitational field strength. Now, we know upthrust is, उसने बताया हुआ है क्वेश्चन में, it is 280 density is 1000, G is 9.8, and we are looking for V. So do you think V will be equal to 280 divided by 1000 and also by 9.8? So 0.028 or 0.030?
0.029.
0.029.
9. Yes.
Should I trust your rounding of skills?
Yes, sir.
Good.
Yeah.
Now, density is mass over volume. Mass equals to weight divided by gravitational field strength. So, do you think you can find density?
Yes.
Okay, hurry up, hurry up. Weight is 32. Gravitational field strength is 9.8. Just one.
112.5.
I have to attend this call. Just give me- So the density will be equal to mass of volume. Mass is weight divided by gravitational field strength. Can anybody tell me what is the answer?
112.5.
100 and
112.5.
so many significant figures. So can I say 110?
Yes, sir.
Good. Okay. Now, the center of the sphere is initially at a height of 6.2 meters per second above the horizontal surface. The speed of the water then increases, causing the sphere to move to a different position. This movement of the sphere causes the gravitational potential energy to. So what does this mean? Decrease. It does it mean that the ball of the sphere has moved up or it has moved down? So if there is a decrease in gravitational field, gravitational potential energy, it means the sphere has moved down and it has lost an energy of 77 joule. Calculate the final height of the center of the sphere above the. So we can find that to lose 77 joule of energy, how much that sphere needs to go down. So change of gravitational potential energy equals to mg delta H. So delta H will be 77 divided by 32. I'm not putting the mass that you have calculated in the previous part. I'm using mg. Mg is the weight. So the product of m and g is 32. So this will be something 2.4 or something.
2.4062.
2.4. Okay, 2.4062, so 2.4 meter. So 2.4 meter, it comes down. And initially, its height was 6.2 meters. What is the final height?
6.2 means 2.4, 3.8.
final height will be 6.2 minus 2.4. That is 3.8. I guess. Then you just 6.2. Yes, 3.7. So final height will be 3.8. Now, the extension of the wire increases when the sphere changes position as described in C. Now, its extension X, identify any other symbol. Oh, I missed something, I think. Okay, describe in C1, the wire obeys Hooke's law. Hooke's law is force equals to extension multiplied by spring constant. State a simple equation that gives the relationship between tension D in the wire and its extension X. Oh, so he's simply asking you to write down the formula. Tension equals to spring constant into X, where he has described tension as T, so don't need to say that T is tension and X is extension. These are already described or explained. The only new variable in the statement is K. So where K is spring constant. Before the sphere changes position, the initial elastic potential energy of the wire was 0.65 joule. The change in position of the sphere causes the extension of the wire to double. Calculate the final extension, final elastic potential energy of the wire after the sphere has changed position. Okay. So he actually, this is one way of examiner to give a question where he does not want you to calculate something. He actually wants you to apply the logic. So you cannot use formula over here because you don't know extension. You don't know the first extension. You don't know the second extension. You just know the stored energy. So you have to first figure out what is the relationship between the energy stored in a stretched wire or cord and extension. And the formula that you have to recall is energy equals to 1 over 2 K X square. So this means that the energy is directly proportional to X square. So here we have energy and X square. So if extension is 1, then energy is 0.65. If extension becomes 2, what will be the size of energy? So let's cross multiply. E multiplied by 1 square equals to 0.65 multiplied by 2 square. So E equals to 1.3, 2.6. So 2.6. When extension is doubled, energy will become 4 times. Okay? Because there is a square relationship between the energy and the spring constant. Energy and extension. Now, I could not find first part of this question. So if you send me that we can complete this one. Let's move on to the next question. This is a question from waves, I guess. Now, the question is, two progressive sound waves meet to form a stationary wave. The two waves have same amplitude, wavelength, frequency, and speed. So they are of the same kind, most probably a reflection of the same wave. State the other condition that must be fulfilled by the two waves in order to form, order for them to produce a stationary wave. Did he mention that the waves are present at the same position and approaching one another in the opposite direction? That is very important because Stationary wave means the energy is not moving anywhere, and that can only happen if one wave is transferring energy in one direction and other wave is transferring the exact same amount of energy in exact opposite direction, and that can only happen if waves approach one another from the opposite direction. Did he mention opposite direction somewhere? Then this is how you answer the question. Both waves must be transferring energy in opposite direction at any point. Now, a stationary wave is formed on a string that is stretched between the two fixed points. If he says a fixed point, it means those 2 points must always be nodes and be t equals to 0 when each point is at its maximum displacement. Distance AB is 0.80. The period of the stationary wave is 0.016 seconds. This is time period. On figure this, sketch the line to show the position of the string at t equals to 0.04 and t equals to 0.024. Oh, good. So remember, if it is a stationary wave, if it is t equal to 0, if it is this, then t equals to 1/4 of time period. All of the points will reach their mean position at t equals to 2/4, which is also 1/2 time period. All of the points will be on their maximum displacement in the opposite direction. And t equals to 3/4 time period, every point will be on the same position again. And at t equals to 1 time period, all of the points will again be on the maximum amplitude as the first position. So now if the time period is 0.016 second, then this is t equal to 0. This will be t equals to 0.004. This will be t equals to 0.008. T equals to 0.012, and this is t equals to 0.16. Sorry, 0.01. And this will keep repeating. Again, the next straight line will be at t equals to 0.020. And after this one, this should be the position again. Okay. Now this means this will be the direction. This will be the position after 0.04 second. So at 0.08 second, they will be here. At 0.12 second, they will be on the mean position again. At 0.016, they will reach the other extreme position. At 0.020, they will come to the mean position again. And this should be their position. At 0.024 seconds. Okay. Determine the speed of the progressive wave along the string. So I have time period 0.016 seconds, and the wavelength is lambda. He said that A and B are 0.80 meters. So if this whole thing is 0.80, then till the center point, this would be 0.40, 0.40. And remember, two loops from node to alternate node, that would be 1 lambda. So my calculation says that the lambda will be 0.40 meter. So speed will be wavelength divided by time, 0.40 divided by 0.016. If I make number of zeros equal, I can cancel decimals. 25 meter per second. You can check with your calculators. I normally make 0.40 divided by 0.016.
Yes, sir. Yeah, answer.
Jazakallah. 25 meters per second. Okay. Now, a beam of vertically polarized light intensity I naught is incident normally on a polarizing filter that has a transmission axis of 30 degrees to the vertical. Now, the transmitted light from the first polarizer after has intensity IT. Light then incident to the normally on a second polarizer filter that has a transmission axis at 90 degrees to the vertical. Calculate IT over I naught. Its formula was, if I'm not mistaken, I was equal to I naught cos square theta. Just let me confirm this one. Okay, that means that if this is I naught and this is I, उसने यहाँ पे इसको IT किया हुआ, then IT equals to I naught cos square theta. So IT over I naught equals to cos of 30 degree square. Cos 30 degrees is under root 3 by 2. So this will be 3 by 4, 0.75. Just check using a calculator.
Yes, sir.
Now, what is I2 over I? Sorry, it is not IT, it is I1. My bad. Now, listen, if this is I1 and this is this will be 90 degree to the vertical. Okay, so it will be I2 equals to I naught cos square theta and I2 over I naught equals to cos 90 square. Now cos 90 is 0. So you should get 0.0.
Yes, sir.
Okay. Now Next question is again from waves. A progressive longitudinal wave travels through a medium from left to right. Figure 4.1 shows the position of some of the particles of the medium at t equals 0 and a graph showing the particle displacement at the same time t naught. Okay. The particle displacement to the right of their position are shown by the position on the graph. This is this. The figure, the period of time, period of the wave is t. On figure 4.1, show figure 4.1 draw circles around the two particles which are exact one wavelength apart. So you can either select from the center of a crust compression to the center of the compression, or you can go for center of rarefaction to center of rarefaction. Okay. So I will go from the particle labeled as X and this particle, because they both are the center of compression. I could also go for these two. These two are one wavelength, and you cannot go for both of them. Okay, remember, you cannot give two answers. Don't ever risk that. Only give one answer. Any one of these two. Configure draw circles to around two particles which are exactly one way. And it's not the only two possibilities. There are other possibilities as well. On figure 4.1, sketch a line on the graph to represent the displacement of the particle for the longitudinal wave at t naught plus t by 4. So quarter of a time period. Okay, if this is t equal to 0, this will be t by 4. This will be t by 2. This will be 3t by 4. And this will be t. So on figure 4.1, sketch a line of graph. Okay, so he wants us to draw the graph. What is the direction the wave is going? Okay, to the right. So this position will go there. The wave goes 1/4 in the forward direction. Okay. You just have to make the wave go quarter of a time period forward. State the direction of motion of the particle z at t equal to 0. Right now, what is z doing? Z is having a negative displacement, so z will be in the. So if something is moving from negative to positive, so it is moving towards right. because it has gone to the mean position. At mean position, the particle must have maximum speed. Now, the frequency of the wave is 16 kilohertz. The direction between the distance between the particle x and y is 0.19 meter. Calculate speed of the wave as now.
Excuse me, sir.
Yes,
Sir, why do we have to draw another wave?
because he says that on figure 4.1, sketch a line on the graph to represent a displacement of the particle. He asked us to do that. A line is showing the displacement of the particles right now. So you have to add another line.
So that means the distance traveled by the waves, like, sorry, the particles?
No. Yes, individual particles.
Okay.
So speed equals to wavelength over time. Wavelength will be, he said that 0.19 meter. How much is 0.19 meter? From X to Z. So this is so this is 1.25 of wave, 1.25 lambda. Because 1 lambda is from there to there. So it is quarter of a lambda more. Lambda equals to 0.19 divided by 1.25. And then time period will be, or we can use F lambda. F equals to 16,000. So speed equals to 0.19 divided by 1.25. So
2432.
sorry,
2432.
2,400 meters per second.
Sir, sir, ये round off करना जरूरी होता है?
Yes. जी 2 figures में कर लें या 3 में कर लें, ये जरूरी होता है. मुझे
तो ये
कुछ कैलकुलेशन सही है.
सर ये लंबा की वैल्यू आपने 0.19 और फिर उसको डिवाइड क्यों किया है?
देखो ना, हमें लैम्डा चाहिए ना, और उसने हमें दिया हुआ है x से z तक का डिस्टेंस. अब x और z 1 लैम्डा नहीं है, वो लैम्डा से ज्यादा है.
सर उसको आपने जिस तरह 1.25 लैम्डा किया तो वही कर देंगे, तो फिर उसको डिवाइड करने की क्या जरूरत थी?
यार हमें फॉर्मूला में लैम्डा की वैल्यू चाहिए ना, 1.2 लैम्डा की वैल्यू तो नहीं चाहिए ना.
ओके सर.
फॉर्मूला में तो हमने लैम्डा की वैल्यू डाल दी थी ना.
ओके सर.
अच्छा, ये हो गया जी. यहाँ तक स्पीड दिख रहा है. वो कहता है लॉन्गिट्यूडनल वेव ट्रैवलिंग थ्रू ए सॉलिड. The initial intensity of wave is I naught. The frequency of the wave remains constant. The amplitude falls to half of the original value. I hope we have done the same kind of question, that what happens to intensity if amplitude is half? we should know that the new amplitude is half. So intensity will be, you can also do it in without any calculation. You should know that it is 1 by 4 times of intensity. You know why? Because if amplitude has been halved, intensity will reduce to quarter, because intensity depends on square of the amplitude. This is intensity, this is amplitude. If intensity is I naught, amplitude is 1. If amplitude becomes 1 over 2, intensity will become x. There are squares on the top of these two, so x equals to 1 by 4 times of intensity naught. So I will say 0.25. If you want to do calculations, there we are your calculation, but if you want to use directly the concept, you can also do that. The sound wave is now in C now meets another sound wave traveling in the opposite direction. State a condition necessary for these two waves to form a stationary wave. Should have same wavelength, frequency, amplitude. Okay. Now, state two ways in which a stationary wave differs from the progressive wave. All points within two nodes are in phase in stationary wave, but not in progressive waves. In stationary waves, nodes and antinodes are formed. 3. Energy of any particle stays same in stationary waves. Okay. Energy does not go anywhere in stationary waves. State Kirchhoff's second law. Total EMF developed in a closed loop is equal to total potential difference in the same loop. Okay. Now, 3 identical cells, each of electromotive force 1.5 volt and internal resistance of 590 milliohm, are connected in parallel across the conductor as shown. The conductor is composed of 2 cylindrical sections A and B. The total resistance of the circuit is 2.2 ohm. Show that the resistance of the conductor is 2.0 ohm. The whole circuit has 2.2 ohm. So I can see that there are like whole circuit. Oh, there are 3 resistors connected in parallel. Their combined resistance is resistance of the 3 parallel resistors will be 0.59 divided by 3. This is a shortcut to find total resistance of 3 parallel resistors, because we know 1 over R plus 1 over R plus 1 over R is going to be 3 over R, and resistance will be R over 3. So we can directly do it as 0.19666. So this is 0.20 ohm. So if these 3 resistors that are connected in parallel is this, then listen. Resistance of the parallel equals to 0.20 ohm. This is total internal resistance equals to 0.20 ohm. Total external resistance equals to X. X plus 0.2 equals to 2.2. X equals to 2.0 ohm. Hence shown. Okay. The 3 resistors over there, they are all internal resistances. So we can find the total internal resistance by adding them by the parallel rule. That would be 0.2 ohm, and total resistance of the whole circuit. And remember, the internal resistance is always connected in series with the external resistance. So it will be 0.20 plus internal resistance equals to 2.2. That will give you external resistance. Now, calculate the current in the conductor. Now, what is the potential difference? EMF each 1.5. I equals to 1.5 divided by 2.2. Don't get misled. The current from each battery will depend on the total resistance. Okay, so do not think that you have to do it anywhere, any other. So 1.5 divided by 2.2 should be 0.67 or 0.7.
Sir, 0.68.
Divided by 0.68.
Yes, sir.
Zero point 0.68 ampere. Now, the 2 cylindrical sections A and B of same material and have same length. The diameter of section A is this, and the diameter of section B is this. The resistance of the section A is RA. The resistance of section B is RE. Okay. Resistance equal to resistivity L over A, or 4 times resistivity L over pi d square. So that means resistance is inversely proportional to diameter square. So resistance A over resistance B should be equal to diameter B over diameter A square. 7.6 over 4.3 square. I'm getting 3.12.
Yes.
Now, calculate the ratio average drift speed. Okay, free electrons in A and B. Now, what do we know about drift velocity? Drift velocity equals to I over A N Q. Okay, or V equals to I over or 4I over pi V square and Q. Now, speed is inversely proportional to diameter square. The diameter decreases, speed increases. Why I'm getting the same answer? I'm hoping to get the same answer. We- There will be more speed in A than B part. So VA over VB equals to diameter B over diameter A square 3.12. Does anybody have a marking scheme for this one? Check. I'm not sure that this should be happening. This is October, November 22, paper 23. Who shared this question? Mubashir, do you have marking scheme for this one? Check, confirm the answer.
Yes.
Hurry up, please.
In 3.1.
3.1 for both?
Yes.
Why did he give the same question twice to give somebody? It is the same working, same everything. Okay, we can have another class tomorrow if you want to, and complete other questions as well.